When the water level of Lake Okeechobee dropped by nearly 4 feet in December 2024, satellite cameras captured something that water managers never predicted.
There's something in the water that may threaten human health, yet it often remains invisible to the naked eye, detectable only under magnification. According to scientists, the chain of events began quietly when Florida officials started lowering Lake Okeechobee to reduce flood danger. As the water slowly retreated, however, many locals sensed that something unusual was unfolding. Along the lake's vast perimeter, tension mounted. Researchers say the transformation started subtly, almost imperceptibly at first. Before sunrise, engines hummed and pumps roared in the heavy humidity as water managers carefully and systematically reduced the immense volume of Lake Okeechobee. For some observers, it was standard procedure, a calculated flood control measure designed to protect downstream communities from overwhelmed levees and sudden storm surges. But for those watching the shoreline recede, residents leaning against pickup trucks, survey teams scanning with binoculars, anglers and birdwatchers studying the shifting horizon, the moment felt far from routine. Anticipation rippled along the lake's edge, and unease seemed to hover just above the waterline. Within hours, the enormous surface of Lake Okeechobee began to change. Features long hidden beneath years, even decades, of murky water started to emerge. As the shoreline withdrew, layers of muck and silt revealed islands of tangled debris, weathered tree stumps, and forgotten contours of the lakebed. Wildlife reacted almost immediately. Herons stood motionless over mud flats that had been submerged only days earlier, while fish writhed in shrinking pools, scrambling toward deeper refuge. Then, as cameras documented the unfolding scene, something else appeared beneath the falling waters. Movement, measured and deliberate, traversed the freshly exposed bottom. It was not merely the frantic stirring of startled fish or marsh dwellers. Large, indistinct shapes slid through the cloudy shallows, leaving unmistakable trails etched across the sediment. From the shoreline, the scene was difficult to interpret. From above, through drone and helicopter footage, the spectacle became clearer, revealing patterns that sparked intense speculation. Social media erupted with theories. What exactly was moving beneath the scarred surface of one of the largest lakes in the United States? Amateur analysts dissected video stills, tracing unusual wakes and elongated shadows. Was it a massive turtle, a concentration of invasive species, or evidence of an ecosystem that had quietly adapted beneath a lake long criticized as one of America's most polluted? The discovery carried both fascination and apprehension. What else, people wondered, had been concealed beneath Okeechobee's opaque waters, only to be revealed by human intervention? The questions reverberated through news coverage, public meetings, and online forums. The urgency felt immediate rather than theoretical. Each update and new video frame amplified the sense that Florida's largest lake, older than the towns and levees surrounding it, was exposing secrets few were prepared to confront. Ecological and human risks suddenly felt tangible, visible to anyone willing to look. Even as headlines focused on footage, scientists issued more somber warnings. Surface phenomena, they cautioned, represent only the most visible layer of far broader and less predictable transformations. Beneath the receding water, biological, geological, and chemical processes were accelerating. Changes that challenge not only our understanding of Okeechobee, but also our broader relationship with Florida's natural core. As sunlight climbed higher over the diminishing shoreline and public curiosity shifted toward concern, a pressing question emerged. When we compel a lake to unveil its hidden depths, are we truly prepared for what we might uncover? The potential danger did not end at the water's edge. If the sight of shadowy figures gliding across exposed silt stirred instinctive fear, it was not without justification. This was no ordinary environmental incident. The footage revealed more than a fluctuating shoreline. It opened a window into a world previously unseen, both biologically distinctive and geologically complex. As water levels declined, the exposed bottom became a transitional landscape, a chaotic stretch of broken shells, stunted trees, and movement both sluggish and swift. Each step toward greater exposure risked destabilizing habitats, releasing long-buried toxins, and triggering dormant dynamics long debated by scientists. For decades, what lay beneath Okeechobee's surface remained largely theoretical, an object of study and concern, but rarely visible in real time. As hours passed, urgency intensified among local biologists and geologists. The lake was transforming rapidly, not only across newly visible stretches of old riverbeds, but within the chemistry of the mud itself, in oxygen-depleted pockets, and in the sudden displacement of countless organisms. Aerial imagery captured striking contrasts between lingering green shallows and vast gray expanses of exposed sediment. Fish floundered in contracting puddles. Alligators traced awkward paths around debris islands. Most enigmatic were the undulating forms carving tracks across the revealed bog, leaving trenches that collapsed and refilled as silt shifted. Mysterious openings seemed to swallow runoff, adding to the sense of instability. On the ground, vigilance intensified. In laboratories, researchers recognized a ticking clock. Every moment of exposure threatened to unsettle a balance built over centuries, disrupted within hours by a necessary management decision. The questions multiplied. Were the movements simple wildlife displacement, or the release of toxins that had long shaped the lake's troubled reputation? What happens when a lake labeled the dirtiest in America is compelled to reveal its underlayers on a timeline nature never intended? Debate gripped both experts and the public. Was this evidence of ecological collapse, or a system straining to establish a new equilibrium? Answers would require patience and rigorous investigation, extending beyond immediate alarm into the deeper history and present reality of Okeechobee's environmental complexity. To grasp the magnitude of events, one must consider the lake itself. Spanning more than 730 square miles, Okeechobee stretches to the horizon in every direction, occupying not only a geographic crossroads, but a central role in Florida's history. From early Everglades drainage efforts to modern agricultural expansion and recurring environmental controversies, the lake has served as both lifeline and battleground. Decades of nutrient runoff have layered its bottom with phosphorus and nitrogen-rich sediment intertwined with remnants of algal blooms. To many outsiders, this contamination remains abstract, a reason to avoid swimming or fishing. But to aquatic biologists like Dr. Margot Trellis, the lake represents a living archive. We understand more about the water column than what lies beneath it, she observed while surveying the exposed flats. When levels drop this rapidly, we witness not only what lives there, but what has been buried. Drones documented algae mats draped over skeletal stumps, luminous egrets stalking receding pools, and creatures displaced from deeper habitats. Each meter of exposed bed is habitat in transition, Trellis explained. Species are interacting in ways unseen for years. Chemicals re-enter circulation. Entire systems renegotiate survival. Geologist Dr. Raphael Valls warned of compounding effects. Lowering such a vast water body, he noted, can destabilize sediments, alter drainage patterns, and trigger chemical releases. Cracks formed in drying substrate. Methane and ammonia shimmered upward under the sun. Old river channels reshaped runoff, creating unpredictable troughs and hazards. Aquatic ecologist Dr. Samira Kwan emphasized the unique convergence of factors: weather patterns, human intervention, and long-standing environmental pressures. Rapid drawdowns can outpace ecological adaptation, forcing sudden and unpredictable responses. Anaerobic sediments, once sealed, react quickly when exposed, releasing gases and nutrients that ripple through downstream systems. Some track patterns likely reflected combined wildlife movements: fish, reptiles, invasive species seeking refuge. Yet not every phenomenon fit established models. Coordinated tracks suggested collective behavior not fully understood. Okeechobee, Kwan acknowledged, retains blind spots. Its hydrological quirks and biological complexity resist simple categorization. Local residents added personal perspectives. Longtime families described bird patterns never before witnessed. Emergency managers reported sinkholes in newly exposed ground and chemical plumes from disturbed mud. Satellite imagery revealed drainage veins appearing at sunrise and vanishing by dusk as mud baked and fractured. As days passed, attention oscillated between relief at reduced flood risk and concern about newly exposed vulnerabilities. Research teams mobilized to tag wildlife, collect sediment samples, and analyze chemical shifts. Policymakers debated whether forcing revelation paved the way for renewal or initiated another cycle of instability. The viral movement beneath the mud became emblematic of a broader truth. Disrupting equilibrium carries cascading consequences. How can urgent safety measures align with long-term ecological stewardship? What latent risks might surface through mobilized toxins or shifting sediments? And how can preparation account for complexities still hidden? For many, the episode marks a turning point in understanding large ecosystems under human and climatic pressures. The greatest lesson is humility, Dr. Kwan reflected. Nature retains memory. Our control is partial at best. In the weeks ahead, as water levels stabilize and shorelines adjust, the drawdown of Lake Okeechobee will likely be remembered less as an isolated event and more as the beginning of renewed scrutiny, a dialogue about resilience, history, and limits. In the exposed roots and vanishing pools, the persistent movement beneath the surface stands as both warning and invitation to observe carefully, to question assumptions, and to recognize that our relationship with the natural world remains evolving and uncertain. As evening settles over Okeechobee's altered edges, one truth endures. Revelation brings uncertainty, and nature retains the power to surprise. In Florida, even familiar waters can uncover new mysteries when least expected.